Okay, now that started. Pop out. Chat. Cool. There we go. All right, so I am trying to get this stuff to work, and it's quite difficult now because I'm running into this wall of chunk or the Rust borrow checker, because I have this group. Try to get down some painting software so I can try to visualize what I'm trying to do. What happened to my new question? Did it get? No, it's here. Yeah. So I'm gonna ask Gemini about this to see if it has some ideas, just to prototype some idea how to solve this. But let's actually check with ChatGPT if there's any good painting software for Arch. What are some good lightweight painting software for Arch Linux? I want to just draw some abstract concepts like arrows and boxes by hand. Oh, not O3 Mini High. 4.0 is good enough. Note taking and sketching with pen and pen support. Pinta. Krita. No, I don't need Krita, it's too heavy. I mean, Pinta sounds nice. This sounds nice too, though. My Paint. Maybe I should try them both. My Paint. I mean, I don't need this. How is Pinta? Let's try My Paint. Okay, so that's 130 megabytes. And what about the other ones? Pinta. What? Pinta doesn't exist. Terminal based. Xornal PP. Okay, this is much smaller. I like that. Let's try it. We can open up a new workspace here. Oh, cool. Look at this. So, hello? There. Okay, we can just scroll. It's pretty cool. Hello. PDF LaTeX. Okay. Cancel. No, this is maybe not. Maybe it is what I need. What can we do? You. Uh, no, this is not what I need. What's the command again? Sudo pacman rns, I think. External pp. Yes. Okay, what about my paint? This is a downside of this keeps happening. 404. Downside of Arch sudo, or at least how I use it. Getting 404 when trying to download my paint. How do I update mirrors? I think I do have reflector. Yeah. What if I just do this? Oh, that was enough. Huh. SYY. Mm. Hmm? Doesn't seem to work. What? It wants a directory with /user. Okay, let's uninstall this. Sudo pacman ns my paint. Yes. Okay, what else? Maybe I'll use Let's try grok here. Lightweight painting apps for Arch Linux i3. So why are they saying pin? Why am I not able to download Pinta? Sudo s pac no sudo pacman s Pinta. Target not found. Getting target not found when trying Pinta. SYYU. Refresh of the package database, update your system. Okay. I mean, I already did this, but yeah. Upgrading Linux. Was that a new Linux? Yeah. Cool. I wonder how that's even possible, that it can like do an update while it's running. Pacman as Pinta. No, target not found. All right. Let's try Pinta. What? Arch Linux install Pinta. Okay, maybe I need to use yay. No, doesn't seem like it's available easily. MT. Yeah, this sounds like what I need. Super lightweight, no frills. Three megabytes. Wow. Let's see what that looks like. Okay. Can we just make it bigger, like 1800? Yeah, okay. Looks like a flag. Okay. All right. Convert to RGB. I want like a new loose changes. All right. Why is it black? Maybe that's fine. Right, so I'll try to... This is at least very simple. Okay, so the problem I have is I have this... I want this to just fill the whole screen. I want like a full screen of canvas that I can paint on. Okay. Okay, what if I just do like 4,000 by 4,000? Yeah, this feels much better. And what is this? Can I'll put this down there. So there are, let's see if I can make this understandable even for myself. So we have dig, an operation. Then we have something called chunk group. And the chunk group in turn holds, at this point, it's like a box of a like a three-dimensional array of materials. Um, yeah, and what about that? Yeah, I don't know. Let's go to Gemini, see if we can get some ideas. So trying to build a sandbox game with chunks, chunk groups for density data in Rust, I'm reaching issues now when trying to dig at the borders of these chunks because the chunks are overlapping there and therefore I need to make changes to multiple chunks when I dig at point at the border. The bar checker is not happy about that. I'll give you the current code and can you then suggest me a good solution to allow for digging at the borders? Write the code for that, please. I'm using the latest Rust. No, that wouldn't be relevant in this case, I think, but I can give it, I'm not using so many packages, so I don't think dependencies will be a problem. Like versioning in its replies. So this is chunk group. Would be fun to write the software that extracts this stuff for me as a prompt. Chunk group, and then we have chunk. Oops. Chunk. Now I turned on shield mode. What is that? How can I turn it off? There. There we go. Now I could delete a message in the chat. Perfect. Right, chunk group. We need material. Chunk/material. And then we have the test. I think that's all. Suggest a good solution, and also reason about it at a high level so I can learn. Thinking process to arrive at the solution. Core issue. Mutable access to all of them simultaneously. However, Rust borrow checker prevents having multiple mutable borrows. Rust borrow checker enforces. Need mutable borrows of a piece of data at the same time. Interior mutability. Wrap each chunk in a ref cell or mutex, getting multiple immutable references. But then using methods like borrow, mute, lock, .unwrap. This defers the borrow checking to runtime. I mean, I don't know if that's a good solution. Yeah, doing this within the dig function is not ideal unless we put that into the chunk group. Index-based access directly addresses the borrow checker by ensuring only one mutable borrow exists at any given moment. Requires changing how dig works, but keeps the core data structure simpler. Modify the get chunk indices. Function already returns. Up to 8, yeah, up to 8 corners. Remove the get mute chunks and get mutable materials. They're not needed anymore, yeah. Iterate through the chunk indices inside the loop. Get a mutable borrow to the material within that chunk. Modify. Goes out of scope at the end of the loop iteration. Yeah. Check if these local coordinates are on the boundary. This is interesting to read actually. If on a boundary, calculate the index of the neighboring chunk in that direction. Add the base chunk index and all relevant neighbor indices to the result vector. Be careful with boundary conditions of the chunk group itself. Don't try to access indices outside of 0 group chunk group size. Consider edge cases, corners, 3 boundaries equal 8 chunks involved. Edges, 2 boundaries equal 4 chunks. Yeah, faces, 1 boundary equal 2 chunks. Yeah. The logic should handle all these. A systematic check for each axis being at 0 or chunk size -1 relative to the chunk origin seems appropriate. Yeah. Update get density at world position. This function uses, this is really good. Update, this function uses get chunk, which needs a similar update to get chunk indices to correctly identify all relevant chunks for reading density. The rest of its logic, iterating and collecting densities, should remain valid. Review and test. Read through the new code. Does it make sense? Does it follow the index-based approach correctly? Ensure the get chunk indices logic correctly handles all border cases. Update the test. It needs to check that the density is updated correctly in all affected chunks. The current test only checks the world position density, which aggregates the results. A more robust test might involve getting references to the specific chunks and checking their specific material points. However, checking the aggregated density via get density at world position is a reasonable first step, assuming that function is also updated correctly. Yeah, the current test might pass even with incorrect border. I think this solution sounds great actually, if it works. Might pass even with incorrect border logic if get density at world position only looks at the base chunk, hiding the bug. Yeah, true. Let's update get density at world positions helper get chunk based on the corrected get chunk indices first. Add more tests for edge and corner digging. Add explanation. Clearly explain the original code failed, why the code failed, and how the new approach solves it by serializing the mutable borrows. Yeah, it's a great approach. This detailed thought process, moving from understanding the core problem to exploring solutions, selecting the best fit, implementing it step by step, and finally refining and explaining, leads to the provided Rust code solution. Wow, this is getting good. I mean, I don't know if it works yet, but it looks good. Let's break down the problem and the solution. The problem. Borrow checker conflict. You correctly identified the issue. Rust's borrow checker ensures memory safety by enforcing strict rules about references. You can have many immutable references to a piece of data simultaneously. Yeah, you can have only one mutable reference to a piece of data at any given time. You cannot have mutable and immutable references to the same data simultaneously. In your original get mutable materials function, oh, wow, look at this reply. Okay, mostly code, but still. Yeah. We are getting a lot of mutable references here. Trying to. Problem here, calling the get mute chunk. Tries to get multiple mutable borrows. This borrows self.chunk mutably. Yeah. When get chunk indices returns more than one index, because the world position is on a border, the loop tries to call self.getMuteChunk multiple times. Each call tries to create a mute chunk derived from mute self chunks. The borrow checker sees this as trying to take multiple independent mutable borrows from the same parent data within the same scope, which is forbidden even though they point to different chunks within the array. The solution: index-based modification. Instead of trying to collect multiple mutable material references at once, we can identify the indices of all chunks that need modification, iterate through them, and for each index in the iteration, get a temporary mutable reference to that specific chunk. Modify its material and then let that mutable reference go out of scope before processing the next index. Yeah, this way we only ever have one active mutable chunk reference derived from self.chunks at any given moment within the dig functions loop, satisfying the borrow checker. Implementation. First, we need to correctly implement get chunk indices. Oh, I need to wrap up actually. Yeah, let's just read a little bit more here. Need to correctly implement get chunk indices to identify all chunks potentially affected. Point exactly on a border belongs to multiple chunks. Yeah. Correctly. Did I not use it correctly? After setting world position. Yeah. Yeah, position of the corner of chunk 00 in this group, it's right. Define a constant for the effective size, number of intervals. Yeah. Get chunks. Calculate the indices of chunks within this group that contain or border the given world position. A point exactly on a border belongs to multiple chunks. Calculate the position relative to the chunks group's origin. Determine potential chunk indices based on division. Oh yeah. Okay, it's chunk size, it's not chunk group size. Yeah, okay. Example, if chunk size is 5, effective size is 4, position 3.9 is in chunk 0. Position 4.0 is on border of 0 and 1. Position 4.1 is in chunk 1. Yeah. True. Need to consider points exactly on the border. A point is on a border if its coordinate modulo, the effective size is close to 0. Use a small epsilon for floating point comparisons. Yeah, I might need to change this logic a bit. hash set automatically handle duplicates. Potential. Wait. What does it mean? Check index floor x and floor x plus 1. Wait. Where does it use DC? And where does base F come from? Oh, here is dy, okay. Yeah, I need to read through this in more detail, but I think I like the overall idea of it. It's returning a vec of positions or indices even. Digging logic. This is interesting. For affected chunk indices, iterate through. The indices for each index get a temporary mutable borrow. That chunk. Here it wants to add some try catch. Or some try, sum and try. It's an option. Sum and none. I don't want to handle it gracefully. This should crash. I just want an error here. If it fails. But I like this idea. This is actually good. I mean, the structure of it. You usually only need one density value per grid point. You might need a strategy to reconcile multiple values, example average, max, or prioritize one chunk. This implementation returns all found values. And we can reuse get chunk indices here. That's great. And then get triangles. Okay, this is actually beautiful. And then it creates, oh, add try get methods, define, no, I don't need that. Define a constant for the effective size, derive clone. Deprecated methods. Yeah. No changes. No changes needed in material. I mean, the density and marching cubes is not a problem. Test adjustments, digging test. Assuming you have these defined in lib. Yeah, I do. If they are in source, use crate, blah, blah, blah. Polygon chunk face border, chunk edge border, chunk corner border. Okay, this is great. I mean, probably want to refactor this a bit. Like make it my own so I understand it fully, but I see the outline of it and I like it. This should work. I just want to keep it a bit more simple. Like I don't want to have these options here. I want it to hard crash. That might be the only thing I need to change. But yeah, cool. I have to get going, but yeah, good session. Good session. Some progress. I feel like now the progress in a session, I mean, it's going slower because this problem is like, yeah, I think the hardest problem yet to solve in this project. Yeah, for sure. So it's more like I need to just think and understand why it's not working and more abstract before I can implement it. But this is good. I see the light at the end of the tunnel of this problem. Cool. All right. Yeah. Thank you for tuning in, and see you next time. Bye-bye. Bye.